see the standard urging you to do that. Statistics per se, now I mentioned bar graph, statistics per se, which is its own science, and it involves its own content, such as the notion of distribution, the notion of center, the notion of variation. That material of statistics proper enters the standards of grade 6. And advanced geometry enters in middle school as well, congruence and transformation. And you'll see in early grades some of the early geometries explicitly supporting the development of notions of continuous quantity, fractional quantities, and structuring space in ways that students will use and need to draw in 3rd grade when fractions are introduced. Now, so far I've talked a lot about early grades. When we look at the evidence about college and career readiness, so let's look at it. I'll stop talking about it, let's look at some. So here's a bar graph, and I'll tell you what the question was asked in the national survey. What percentage of educators reported that their students are prepared for college-level work in mathematics? Now, there's a very tall bar that is 89%, and there's a very small bar that is 26%. And I'll let you guess which of these are the high school teachers and which of these are the college instructors. The survey comes out every 2-3 years. The new survey came out, I think the numbers were 91% and 26%. There's a stable finding. There's more here than just the inevitable griping of the people downstream about the people upstream that we all do in school. You know, I was that college professor who griped about the high school teachers too. There is an actual disagreement here about what's going on. And you know, it has consequences for kids. They get to college, they find out, gosh, you know, I did what I was expected to do in high school. I got pretty good grades, and I'm getting here, and they're telling me I'm not ready, and now I'm paying for a class that adds time to my degree, paying it out of my pocket, and puts them at greater risk of not finishing. And we all know those risks are greater the further down the socioeconomic scale you go. So there's work to do to set the agenda in high school math so that students are prepared for post-secondary education and training. Early information on this is a study that David Conley is one of the national experts on college readiness. The study came out, he began it right after the standards were published. It's one of the first pieces of validity evidence that we have for the college, for the Common Core in terms of college and career readiness. It's just a survey. It's not a longitudinal study of outcomes, yada yada, right? We're not in a position to do that kind of work yet, but he and his team surveyed almost 2,000 post-secondary instructors from a very wide range of majors, programs, business, I can read them here, mathematics, science, social science, business management, computer technology, healthcare, and he even let the English language arts teachers give an opinion. Of course, you have to, for math, you have to separate out most of what they say. It's interesting. But this is a very broad-based survey, 2-year institutions and 4-year institutions. It is a sort of a picture of college. And went standard by standard and asked the instructors a number of questions. Said, how important is it that students learn the material referred to by this standard before they get to you as a prerequisite for what you do in your course, your introductory course? Asked, how relevant is this to your course in the sense of using it every day? And you rate these things 1 to 5 and so on. Is this introduced in your course for the first time? So a number of related questions that speak to how important the material is, quote unquote, for college. And so there are a number of data points for each standard. Just heuristically kind of mash them together into a kind of importance rating. And then roll it up to the cluster level. You get a bar graph like this. Each bar is one of the clusters in the high school standards. And on the vertical is in arbitrary units, a heuristic scale of how important the stuff in that cluster is. And you see, number one, a huge dynamic range here. There's some stuff that is, high importance off the chart, and there's some stuff that is much, much less important to the post-secondary instructors who are, in a way, the clients for college and career kids. I've grouped them here by the major content categories. So the leftmost mountain is, sometimes when I do training and professional development, I leave the labels off the bottom and see if people can assign the right content to the right levels. So sorry to give it away. The leftmost mountain is algebra. Next, the second one is functions. Now there's a third one which you might not be able to see. It's more of a foothill. It's to the right of the functions. Any guess? Geometry. People tend to get that one right. And then we have number and quantity is the spike there. And then finally statistics and probability. Now, there are a lot of interesting messages here. One of them is, gosh, it's funny because I thought statistics is pretty relevant to today's world. How does it sort of not score as high as this awful formal algebra that people keep writing bad things about in the New York Times? My interpretation of the data, and I think it bears it out if you look at, we'll look further, is that yes, statistics is important to a very wide range of fields in college, but many college instructors are happy to teach it to you. But what they need kids to know coming in, what they can't undo, is a kid who gets to college without algebra. So this is the same data sorted just in a, what do you call it, a screen font. And it makes the point that, across the domains, there is a kind of a shelf of stuff that we better be spending a lot of time and a lot of our care on, particularly. Here's the standard by standard data. Anybody heard of astronomer? Astronomy stuff? He started off life as an astrophysics major. Oh, I graduated as an astrophysics major. I think it looks like a Hertzsprung-Russell diagram, stars, but each dot is a Common Core standard. And basically, if you're in the upper left, it is both felt to be prerequisite by college instructors and felt to be relevant to the actual post-secondary class. So the upper left is kind of more relevant. Lower right means it's less relevant to my class and less important as a prerequisite. If people are interested to have a printout of this, they can get a printout to it, but there is a little, I always want to make the joke, G for ghetto, down in the lower right. All the geometry dots down there form a little fog. I don't know what to say. And then there are some surprises. There's a big G here and there. There's some big N's about numbers. And then there's some statistics stuff and some function stuff. So there's some interesting patterns in the data. Of course, you could stare at all these little dots for a long time and not realize that the post-secondary instructors also care a lot about, especially one of the standards for mathematical practice, which are not shown in this graph. Any guess what the one is that they really interested in? Yeah, I hear the word perseverance a lot. Standard for mathematical practice makes sense of problems and persevere in solving them. And I think, Alan Schoenfeld, I've heard him speak, and he gives a interesting observation. He has a list of 5 funny things that kids learn about mathematics in school. And one of them is that every problem can be solved in 5 minutes. I remember the shock I had, certainly, going to Williams College and signing up for a physics class and finding out that a problem might take a whole page, or the front and back of a page. And I think we could be doing things to lessen that sense of shock. And we'll look at some problems here in the breakout session as well. So in terms of emphasizing in high school, and we can talk nitty-gritty details, about topics or the way they handle geometry, talk about how that looks. But the math practice is particularly the perseverance question, putting together a string of steps as opposed to finding, the one formula that gets you a one-shot answer. That skill not helpful in college. I think taking it out of standard speak, modeling, and rich applications also, again, going to serve kids really well.